Dalton's law is also called Dalton's law of partial pressures. We already know what pressure is. Collisions of gas particles on the container wall. Given a constant volume and temperature, the number of particles in a gas sample is directly related to the pressure of that gas. The more particles there are, the more collisions will take place between particles in the container wall. If we have fewer particles, we have fewer collisions. And if we have fewer collisions, that means there's a lower pressure. If we have more particles, that means we have more collisions. And if we have more collisions, that means a higher pressure. Now, if we have two containers with the same number of particles, but one has the same particles and one has two different types of particles, they'll have the same total pressure because pressure is only dependent on the amount of collisions we're having, not on the identity of the gases. So the total pressure is dependent on the number of particles, or the number of moles, and is not dependent on the type of particle, if the gases are ideal gases. This is Dalton's law. John Dalton, in 1802, published his law that in a mixture of non-reacting gases, the total pressure of the sample is equal to the sum of the partial pressures of the individual gases. What that means is the total pressure is the sum of all of these gas 1 particles plus the pressure from gas 2 particles plus the pressure of gas 3 particles. Here's a Dalton's law problem. In a sample of neon, argon, and helium gas, the total pressure is 2 atmospheres. The partial pressure of helium is 1 atmosphere. That's the pressure that's contributed to helium hitting the sides of the container. And the partial pressure of argon is 0.2 atmospheres. What is the partial pressure of neon? So we know that the total pressure, P total, is equal to the pressure contributed by just the helium gas plus the pressure contributed by argon gas plus the pressure contributed by neon gas. We know the total pressure is 2 atmospheres. So 2 atmospheres. We know the partial pressure of helium is 1 atmosphere. Argon contributes 0.2 atmospheres. And we don't know the pressure contributed by neon, but we can solve for it. Partial pressure of neon is 0.8 atmospheres. So this only works if all of these pressures are in the same units. It might be atmospheres, it might be torr, it might be millimeters of mercury, but you can't have mixed gas units. They all have to be the same. Where do we find a gas mixture of non-reacting gases? Well, there's a place where nitrogen, oxygen, argon, carbon dioxide, other noble gases are found. It's called the atmosphere. Another example would be the tank of a scuba diver. You have a mixture of gases in there as well.